So each of these are rotations about standard axis. None of this is about a unconventional axis like k theta. So this is x p. This is about the z axis, z theta. This will be x psi, and here you have z alpha. Okay. So your resultant matrix R3 by 3 will be equal to. Now it does not matter if the first one is world or current. World is fixed. Okay, whenever you see world global, it is a fixed axis. Current is obviously current, right? There is no change in this world. But some books follow a global axis, fixed axis, world axis. It only means it is a fixed axis. If you see any of these words, it means this is a fixed axis rotation. This does not change. Okay? World or global, it means a fixed axis rotation. The first rotation, obviously, makes no difference if it's a current or a fixed axis. So you'll write it as R, X, phi. Alright? This is your first rotation. Rotate about, the second rotation is about, again, a fixed. So this should be pre-multiplied because it's a fixed axis rotation. So we'll go here. RC theta. Okay? This is the second one. Then you have a current x-axis. So current is post-multiplied. So this will be alright. And finally, again you have a fixed axis. So this will be Z alpha. Will be here. So this is your first rotation. One.
Z alpha.
Z alpha. So we started with this. This is your first rotation. The second one was Z theta, 2. This was your third rotation. And this was your fourth. Okay. That is your composite rotation matrix. Okay, so we'll come back to this, or you will be using this when we do the 4x4 homogeneous transform. Let's go to doing inverse Euler, and then we can move on to the 4x4. So one thing that I want to explain before we do inverse Euler is a different way of calculating the inverse angles. Let's say we have a coordinate frame like this. This is x0, y0, this is your origin, O0. Let's say I have a point Px comma y. Okay, Px comma y. I have this as theta. Okay, so this is obviously y, and this is x, right? We know this. And let's say if this is r, that is the length of the line, r, then I can say that x is equals to r cos theta and y is equals to r sin. Right? That is pretty simple. So I can express theta as tan inverse of y over x.
Professor, one more time, you are calculating what?
I'm calculating theta, right? Theta. So x is equals to r cos theta and y is equals to r sin theta. So theta will be tan inverse of y over x, which is straightforward. I mean, this is elementary. Okay. The way we'll represent it from now on, or at least for the purposes of solving this problem, is we'll write this as theta equal to r tan a tan 2. That is a different form of representation. We'll write it as x comma y. Okay. So instead of y over x, instead of representing tan inverse like this, I'll write it x comma y. In coordinate frame we write, every time we write a coordinate, we write it as x comma y. So this will be a tan 2, this is a different form of representation, r tan x comma y, or I can write this as theta equal to a tan 2 r cos theta comma r sin theta. Okay. All right. We'll represent it like this, r cos theta comma r sin theta. The advantage is, if the point moves down, then this will become, let's say this moves down. If this moves down, then y is negative, right? So then I'll know if the point is, let's say here, then this will be, assuming the point is here, then I'll have theta equal to a tan 2 x comma minus y. So I know which coordinate it's lying, which quadrant of the coordinate system, first, second, third, where it is, based on which one of these two or both are negative, I can tell where x and y are located. So for example, here both are positive, x and y are positive. In this case, both, x is positive, y is negative, here both are negative, and so on. So you can, by looking at the coordinates here, you can tell what should be the angle, because you know in which quadrant of the frame, of this frame F0, you have the point located. So this will give you an idea instead of just having a ratio like this. This ratio will not tell you exactly where it is, but if you represent it in coordinate system x comma y, you can tell whether it lies in the first quadrant, second quadrant, third quadrant, and so on. Okay. So, yeah.
Is it a tan 2?
A tan 2. A tan 2. So theta will be equal to, this is r tan. R tan is a tan inverse. R cos theta, comma r sin.
And a is like
R A R C. R tan is tan inverse. Okay, 2 means it's a different notation as opposed to A tan is a standard notation. A tan is y by x. So we'll use this form of notation to solve, the inverse Euler problem. So what is the inverse Euler problem? Inverse Euler problem is if I give you a matrix like this, a 3 by 3 matrix, and you have to find the Euler angles. Find Euler angles given a R3 by 3 matrix. Okay. Some cases you can get straightforward 3 angles. In some cases you'll have infinite set of solutions, as you will see. So if you remember, your R Euler is equal to a z by z notation, which is R z. So let's write down the matrix I gave you previously so we can use that to construct the inverse, or let me write it here. So R z by z, which is Euler, was equal to cos phi cos theta So we need to find these angles. We need to find the orientation matrix, find orientation angles O. Let me write it as orientation. Because they can also mean RPY. They have, even RPY is phi, theta, and psi, right? There is no difference between the two, unless you specify how they have been multiplied, okay? So this is a post-multiplication case. All right, now let's say that this matrix is equal to, let's say this is equal to, because we cannot write this whole thing all the time, let's call this as we'll call that as a rotation matrix, and each of the elements is defined by their row and corresponding row and column. Okay. Now, when we discuss the properties of rotational matrices, we assume that all of them, not assume, it's a property of the rotational matrices that they are orthogonal and the determinant is 1. And all of them, any row or any column is a unit vector. So let's start by assuming that these variables here, if you remember, usually matrices, if you look at the rotation matrices, in this case, because it's Z, it could be, might as well end up like this, with this one being R11, R12, R21, R23, right? It could be like that. So let's say for the first case, case 1, let's assume that these elements are not zero, okay? We'll assume first that these elements are non-zero, all right? So, assume R, this one is R13, comma, R23, and these two, R31, comma, R32 are non-zero. All right? These are non-zero. So if this is non-zero, cos theta we have here. So cos theta is R33. Right? Okay, cos theta is R33. If cos theta is R33, sin theta will be equal to plus or minus square root of 1 minus. Right? So we have, this is case A. Let me call this as case A. So we are assuming these values are non-zero, these two are non-zero, and cos theta is equal to R33, obviously this will be sin theta. So if this is sin theta, we can write theta in R2 form. So we have theta will be equal to A tan 2 R33, which is cos theta, comma, right? Cos theta, sin theta. As I explained to you, in this notation we'll write cos first and then sin. This is one solution, or you can have theta is equal to minus, because theta in this case A tan okay. Here theta is positive, theta is greater than 0 or positive. In this case, less than 0. Because we have a negative sign. Okay, so let's consider this case, okay? If, first one is if theta is greater than 0, in other words, theta is positive, we need to find phi and psi, right? So let's take these two, all right? In this case, R13 is equal to cos phi psi, and you have R, this should be, because in this case we won't get anything, right? This should be sine. Yeah, please change this to theta, I'm sorry, change this to theta. Otherwise it doesn't make sense, we won't have any value to get out of it. Okay, all right, so this will be R23, will be this angles, sine theta. Okay, so this will imply from here, you can say phi will be equal to A tan 2 cos
Sine
sine
theta.
theta. Again, okay, this has to be speeded. R13, comma, R23. Okay, cos and then sine. All right, so you have theta, phi, and we need to find psi. Psi you will find from these two here. So R31 will be equal to sine theta cos phi. This will be equal to sine theta sine. So from this you can say psi will be equal to A tan 2 R13 okay. Usually we try to write this as negative. I'm going to write this as negative to show that this is a negative sign. It will show you which quadrant it lies in. Okay, that's the only purpose. It does not mean that I'm changing the sign of the number. No, it only shows you which quadrant it is, which is why we use x comma y notation. This is to show you which quadrant that point lies in. Okay, so this is only to show okay. Or you can set up the sign right here and then you can do that, that's fine. Okay, let's take the other case where theta is negative. Okay, now we did if theta is greater than 0, we finished this. The alternative case is obviously if theta is less than 0. So if theta is less than 0, sine theta will be negative, right? Obviously, if theta is less than 0, sine theta will be negative. There is no change in cos theta because it will remain the same. So this will become minus because sine theta is negative. So R13 will become negative. So this will be R13 negative because sine theta has become negative, right? And this will also be negative. Okay, so I add a negative sign here because sine theta is negative. This negative sign is because theta is negative. So we'll have phi as same way, let's take these two. Now previously we wrote it, so this will be R31 will be equal to cos phi and R32 will be equal to sine theta. Now this will become positive because negative of negative, this will, let me write it like this. Use a different pen so you know that I added this later. So this will become positive because it's negative of negative. Sine theta is negative. And this is also negative, so I'll add a negative sign. Okay? So here you will have side will be equal to Alright, so previously we assumed that these are non-zero, right? So, and we solved this assuming that this is all non-zero. Let's say we have them as zero. So case B is these and those two are equal to 0. So R31 is equal to R32 is equal to 0 and R13 is equals to R23 is equals to 7. Okay. So these are 0. So if these are 0, what values can cos theta assume? 1. Just 1 or any other value?
1 minus 1.
1 and minus 1 because it's a unit vector. The only option here left is 1 or minus 1 because they are unit vectors. So eventually, when R3 is equal to 0, this matrix will turn into R11, R12, 0, R21, R22, 0, 0, plus or minus 1 because it's a unit vector. When you take the magnitude, even if it's a negative, you'll have a magnitude of 1. So cos theta is left with these two. When you assume these two values to be 0 and 0, the only option here to make it still a unit vector, this row, to make this row a unit vector and to make this column a unit vector, the third R33 can only assume two values, 1 and minus 1, right? So we have again two options, right? If cos theta is equal to 1. Alright, if cos theta is equal to 1. So in this case, what it means is R3 by 3, R33 is equals to plus or minus 1. So cos theta is equals to plus or minus 1. Right? That's it. So when I substitute cos theta is equal to 1, this obviously implies sin theta is 0. Because cos is 1 at theta equal to 0. this means theta is equal to 0 degrees, okay? Which again means sine theta is 0. So if you substitute this sine theta equal to 0 in here, or cos theta equal to 1, you will have RZYZ will be reduced. This will be reduced to cos theta is 1, so this will be cos phi cos psi minus sin phi, right? Here this will become 1, so this will be equal to sin phi cos phi plus cos phi sin, right? This is 0. Here again let's substitute minus, so this will be negative cos phi cos psi minus this will be 0. No, this should be cos phi. Let me check. This has to be sin phi. Otherwise we can't get, we won't be able to get this. Give me 1 second. This has to be sin phi. Make this sin phi, please. My apologies. Oh, I assume that. Okay. Okay, so this will be cos theta. This has to be, I'm sorry, this has to be sin. Make this as. Thankfully, we haven't used this term, so whatever we have done till now will not be affected. Okay, I hope there is, that's it. Okay, so this is 1, so I'm going to write this as cos phi here. Okay,
Sir, R22,
R22,
cos phi, no, cos chi, last term.
last one, sin phi, sin, sin phi, cos phi, sin psi. All right, so if we use this identity, this is nothing but, you can reduce this as cos phi plus psi. Okay, cos A plus cos B, cos A cos B minus sin A sin B. Same thing here. This will be sin theta plus sin A cos B, cos A sin B. This will be negative sin phi plus psi, and this will be cos phi plus psi. So we can find phi plus psi, phi plus, let me write it like this, R11 is cos phi plus psi, R21 is equals to sin So here you will have phi plus psi will be equal to A and 2 cos first. So this will be R11, comma R2. Okay. Now this is a sum of two angles. So sum of two angles coming up to a constant value. So this will be phi plus psi will be equal to some value k, which is whatever this equals to. Let's say 30 degrees, 40 degrees, 50 degrees. So you can have infinite combinations to add these two and come up with this number, with the total sum of this. So phi and psi can assume infinite values
R2 and last term is sine chi or cos chi?